So if you're not familiar with XR, it's a software operating system that runs on carrier-grade Cisco routers. So for this artifact, we're kind of assuming already that the file image is accessible to the device already, whether over TFTP or on local storage media on the device. It'll do the entire upgrade or downgrade process, either zero touch with no manual intervention required at all, or also a verbose mode, which will give you extra error logging and debugging information. There's also an option where you can run all of the installation commands against the device in admin mode. So a little bit of terminology. You can select PIs and SMOOs. PIs are package installation envelopes. SMOOs are software maintenance upgrades. So the PI is going to be the main installation image. SMOOs are optional. They're like I said, maintenance upgrades that go along with the main installation, so they can be installed after the PI is installed. I'll take the screen share so I can go over kind of the main workflow itself. So the way that it started is through automation catalog, like most of our other artifacts. You can choose from the drop-down list one of the devices. Keep in mind that at the moment we're only supporting Ansible devices for this. There will be NSO support in a future update. So you got to supply the location for the main image as well as the file name. SMOOs, like I said, are optional. This part here is mandatory in the form. So this is basically a table where you can just supply as many of the SMOOs as you would like. At the bottom, you've got these options for verbose and zero touch. So obviously you can't enable both of them simultaneously. Verbose mode, like I said, will give you extra information, including command template results, and zero touch will run the entire automation end-to-end without any interaction required, with the exception of error handling that may occur. So this is the main workflow. I'll kind of walk through it quickly, but basically what's happening is first querying the device to get the device details, making sure that it is in fact an IOS XR device, checking that the PI image exists and any SMOOs that are provided also exist and are available to the device. Next, it's going to do a series of pre-checks on the device. This is a command template that's kind of intended to be customized. And all of these can be run with the admin in admin mode. These rules are left blank, which are kind of intended to be filled in by the user and totally customizable. The next step is going to be the failover, which is where network traffic is going to be rerouted. This I've just provided as a stub task, and the intention is the logic will be implemented by the user. Same for the restore, which is at the very end where network traffic is routed back to the device. The upgrade process itself is a separate workflow. This is kind of doing the lion's share of the work here. So it's basically a series of command templates that run, and after every single command template that runs, there's going to be this child workflow that handles the async installation process. So the nice thing about this is the modular design. Any other installation commands that you want to run, you can just run the command template and then run this child job with the async operation. And what this is going to do basically is query the device periodically. I believe it's set for every 30 seconds or so. Check if the installation process has succeeded. If not, if there's any sort of error, it'll actually query the device and show you the logs. Got a photo of that down here. So it'll query the device and show the logs to you in a manual task, so you can do some debugging and figure out what exactly went wrong. If it times out, it'll exit with an error. After about, I think, querying it 20 times or so, it'll log out. Next step after that is it's going to ping the device until it comes back online. This is basically just a device connection health check artifact, which we already have. It's going to do commit and clean up the installation repository. So in between here and the ping is where the device will actually reset. After the commit, it's going to do the exact same process for any smooths that were provided. So the smooths are done after the Pi is done. Afterwards, it's going to present you with post checks. So again, if you have the verbose mode enabled, it's going to show you the command template results for these. Finally, it's going to show you the template diffing for the pre and post checks. And this will kind of look something similar to this image here, where it'll show you what the diff is between the pre-checks and the post-checks. The final step, of course, is going to be restoring network traffic. Again, that's left up to the user to implement. And that kind of wraps it up.